Good morning, all of you. In the previous class, we have discussed about the Bernoulli theorem as well as the application of Bernoulli theorem. Also, we have discussed. That means the Therese theorem as well as the Venturi meter. Also, we have discussed. Okay. So today we will discuss about the some numerical that is related to the Bernoulli theorem as well as the equation of continuity and Therese theorem. Okay. So first numerical number 1. Numerical number 1. Question is what water flow through a horizontal pipe. Question is that water flow through a horizontal pipe of a varying area cross section at the rate of 10 cubic meter per minute. Okay, it is given that water flow through a horizontal pipe of varying area cross section of a 10 cubic meter. That means volume it is given 10 cubic meter. So volume it is given 10 cubic meter. Okay. So and determine the velocity of water at a point where the radius of pipe is 10 centimeter. So you have to determine the velocity of water at a point where the radius of pipe is 10 centimeter. Radius it is given 10 centimeter. Radius it is given 10 centimeter. It is given. Okay. So two things are given. Only velocity, that means the volume is given 10 cubic meter, as well as the radius it is given the 10 centimeter. It is given the radius given as well as the volume of the water that is given also. So you have to find out the determine the velocity. You have to find out the velocity. So how can you find out the velocity? What are the given things we have to first read? So that means first of all, rate of flow of fluid is how much? Rate of flow of water. How much water is flowing per second? That means uh, it is given 10 cubic meter per minute. It is given per minute. It is given. So you have to convert it into second first. Okay. So you have to convert it into second. So that means so whatever the value is given, that means 10 cubic meter per second. So that means 10 cubic meter. That means per second means it is given per minute. So you have to convert into second. That means 60. For you have to divide 60. Okay. So 10 cubic meter cube, that means meter cube we can write 10 meter cube for 60. 1 minute equal to 60 seconds. So you have to write 10 meter cube divided by 60. So that will be 1 upon 6. Okay. So 1 upon 6 is the rate of flow of water. That means that is the value of Q it is given. Okay. Q means how much water is flowing per second. How much water that is flowing per second, that we have to divide, the symbol of Q. Okay. So Q equal to rate of flow of water, that is flowing per second. That means 10 meter cube, it is the what volume of the liquid that is passing, divided by per minute. Per minute means 1 minute is 60 seconds. So 10 upon 60, that is 1 by 1 upon 6. Okay. So this is the Q we can find out. Okay. And radius it is given 10 centimeter. That means if you convert it into meter, that will be what? 0.1 meter. Radius it is given 10 centimeter. If you want to convert into meter, 0.1 meter. Okay. So we know that one formula, that means Q equal to area cross section into velocity. Q equal to, from the equation of continuity, one formula was there, that means Q. That means if you want to find out the what Q equal to A into V. A means area into velocity. So A equal to what? Pi r square. Area equal to, formula of area is pi r square into V. Okay. So if we want to find out the value of V, then V will be how much? Q divided by pi r square. This is the formula. That means Q divided by pi r square. Okay. So Q value means how much? Q it is given. Q equal to 1 upon 6. 1 upon 6 divided by pi r square. Pi means 3.14 into r square. R square means 0.1 square. Okay. 0.1 square. So if you calculate these things, that means 1 upon 6. 1 upon 6, you just take 6 as a denominator. 6 into 3.14 into 0.1 square. Okay. So if you calculate this, then what is the value? The value will comes to 5.303 meter per second. This is the value of water. V. V is the velocity of the fluid, that is the fluid. Okay. This is the first question. Question number one, that is telling that first what is given to you? Volume of the liquid, that is 10 cubic meter per minute it is given. Per minute. Okay. Per minute it is given 10 cubic meter, and radius it is given 10 centimeter. Radius it is given 10 centimeter, and 10 centimeter equal to 0.1 meter. So if you want to find out, first you have to find out the q equal to rate. Q means what? Rate of flow of water per second. Okay, so per second means it is given per minute. It is given per minute means what? 1 minute equal to 60 seconds. So you just divide 10 upon 60, that will be 1 upon 6. You will get the what value you will get? 1 upon 6. So you know that formula, q equal to area into velocity. Q equal to what? Area into velocity. So area means pi r square into velocity means v. Okay, so v, you can find out the v equal to q upon pi r square. So that will be, q value is 1 by 6, I have already find out, and pi means 3.14 into 0.1 square. Okay, so it will value comes to 5.303 meter per second. This type of question. Okay, so let's solve another numerical. Next question. Water flows through a horizontal pipe. Water flows through a horizontal pipe whose internal diameter is 2 centimeter. Whose internal diameter it is given 2 centimeter. It is given. Okay, and it is flowing at a speed of 1 meter per second. Okay, so question is asking what should be the diameter of the nozzle. One nozzle is there also. So what should be the diameter of the nozzle if the water is to emerge at a speed of 4 meter per second? If the water has to emerge out with the speed of 4 meter per second, so what's with the diameter of the nozzle? Okay, so diameter means, if you want to find out the diameter, that means first of all you have to find out the radius. If you know the radius, you can find out the diameter. Okay, so I'm repeating again the question is telling that water flows through a horizontal pipe. Water flows through a horizontal pipe whose internal diameter is 2 centimeter. Internal diameter it is given 2 centimeter, and it is flowing with the speed of 1 meter per second. Okay, and what should be the diameter of the nozzle if the water is to emerge at a speed of 4 meter per second? Water has to be emerged at a speed of 4 meter per second. Okay, so what it is given, first we have to note down what are the things that is given. Okay, d1 equal to how much diameter? 1 it is given how much? 2 centimeter. 2 centimeter. D1 it is given how much? 2 centimeter it is given, and at that time the speed was 1 meter per second. The velocity v1 equal to 1 meter per second. It is given in the question. It is given. So d1 it is given 2 centimeter, as well as v1 it is given 1 meter per second. Okay, so d1 2 centimeter means, if you convert into meter, then it will be 0.02 meter. Yes or no? So 2 centimeter divided by 100, so it will be 0.02 meter. v1 it is given 1 meter per second. 1 meter per second. And v2 means one nozzle is there. Okay, one nozzle is there. In that nozzle, the water speed is 4 meter per second. Water speed is how much? 4 meter per second. It is given. But you have to find out the radius. Okay, you have to find out what? The radius. Radius. After that, you can find out the diameter also. Diameter also you have to find out. It is given 4 meter per second. So who can do this question? Raise your hand. Anyone? Shivans?
Yes, sir.
Can you do this type of question? It is given diameter, it is given velocity, it is also given first velocity is given, and the second point velocity, second velocity also given, a radius you have to find out.
Yes, sir. My answer is coming 0.5 centimeter.
0.5.
Yes, sir.
0.5 means which radius or diameter?
Diameter.
Diameter is 0.5. It is incorrect. Diameter will comes to different answer will be there. Okay, so we'll solve it. Okay, anyone who can do it? Ron Thomas.
Sir,
Yes, Ron, can you do this type of question?
no, sir.
Okay, okay, we'll solve it. Okay, so question is given that diameter it is given 2 centimeter, that means 0.02 meter. V1 it is given 1 meter per second, and V2 is given R2. You have to find out V2. V1 means, sorry, it is diameter 1 it is given. So you know that one question is one formula is there. That formula says that means equation of continuity. Equation of continuity tells what the equation of continuity tells that A1 into V1 equal to A2 into V2. Is or no? A1 means area, first area. Okay, that means AB remain constant. This is the equation of continuity. Area into velocity remain constant. Okay, if a liquid is flowing through on different cross-sectional area will be there. In the first phase, the cross-sectional area will be A1, and the velocity will be V1. And the second pipe, that means it's same pipe but different cross-sectional area. A2 it is there and V2 it is there. So A1 V1 equal to A2 V2. Is or no? So A1 means what? A1 means it is pi r square, area pi r square, into V1 it is the pi r square into V2. Is or no? So, and here r is not given, here it is given d1, it is given diameter, it is given, and we know that r1 equal to diameter upon 2. Is or no? Radius equal to diameter upon 2. So we can write here it is 2. So pi r, in place of r1 square we can write it d1 square upon 4, because d1 upon 2, so square it is given, so d1 square upon 4. Yes or no? Second, v into v1 equal to pi into d2 square divided by 4 into v2. Yes or no? This is the value. Okay, so you want to find out the which from, that means d2 we have to find out. So 4 can be cancelled from both sides. So d2 equal to d2 square equal to how much? Pi into d1 square, okay, into v1 divided by pi into v2. Okay, pi also can be cancelled from both the sides. So what is remaining? d1 square into v1 divided by v2. d1 square into v1 divided by v2. So yes, Sivans, what is your answer?
Sir, 1 centimeter.
Yes, 1 centimeter is the right answer. Sugandha as well also solved it. Sugandha, what is your answer?
So my answer is 0.1 meter.
0.1 meter.
Meter.
0.01 meter. It will be answer will be 0.01 meter, or it will be 1 centimeter. Okay, I am solving just to see the procedure. Okay, so that means here, so d1 it is given, d1 how much? D1 it is given, d1 it is given 2 centimeter or 0.02 meter. 0.02 meter, 0.02 meter, okay, into d1 square, so 0.02 square. Okay, then v1 it is given how much? V1 equal to 1 divided by v2 it is given 4. Okay, so if you solve it, then what will the answer? Just I am solving 0.02 square, that means that will be what? 0.02, just write down 0.02, 2 into 10 to the power minus 2 square. Yes or no? 0.02, in place of that you can write 2 into 10 to the power minus 2 square into 1 divided by 4. Okay, so the answer will be comes to, so we just square it, 4 into 10 to the power minus 4 into 1 divided by 4. 4 can be cancelled, so only remaining is 10 to the power minus 4. Okay, so it is a d2 square. Okay, so if you find out, you want to find out d2 only, so 10 to the power minus 4 the square root, that means that will be 10 to the power minus 2, or 0.01 meter. 0.01 meter. Okay, 0.01 meter. and if you want to convert into centimeter, then it will be 1 centimeter only. Okay, so this is the second question we have discussed. Third question comes to third question. Question is given, at what speed will the velocity of the, at what speed question is given, at what speed the velocity of the head of the stream of water be 40 centimeter. It is given the question, at what speed. Okay, speed is question is asking about the velocity. You have to find out the velocity. Will the velocity head of the stream, velocity head means what? V square upon 2g. Okay, 2gh. Okay, that is called the velocity head. So that means you have to find out the what, at what speed, that means the velocity you have to find out. Okay, so it is given at a height, it is given 40 centimeter, 40 meter or 40 centimeter, it is given 40 centimeter, it is given, height it is given, and g value you know that 9.8 meter upon second square. Okay, if the speed liquid is flowing towards the downward, that means from the height of 40 centimeter, you have to find out at what speed, the liquid will flow, that means v you have to find out. Okay, so how can you find out the V formula? Is that V square equal to root over of 2GH? Yes or no? This formula you just to put out and find out the answer. Just put this formula V square equal to V equal to root over of 2GH. This formula you just to put and you can find out the answer. GH it is given, G also given 9.8. Yes, Shivans.
Sir, 2.8.
2.8. Okay, meter per second. Okay, it is correct answer, 2.8, or you can write also 280 centimeter per second. If you want to convert into, that means it is given centimeter, also you can, the answer will be 280 centimeter per second. If you want to convert into meter, then it will be 0.4 meter, then answer will be 2.8. Okay, so both the answer will be correct. Okay, just to put this formula, you can get the answer. Okay, so next question. Next question, at what velocity water emerges from an orifice in a tank? It is based on the Therese theorem. Okay, so at what velocity does the water emerge from an orifice in a tank in which the gauge pressure it is given 3 into 10 to the power 5. Okay, pressure it is given how much? Pressure it is given 3 into 10 to the power 5. Okay, so Newton upon meter square. Okay, so pressure it is given 3 into 10 to the power 5. At what velocity does the water emerge from an orifice in a tank in which the gauge pressure is 3 into 10 to the power 5 Newton per meter square? Before the flow stat, this was the pressure. Okay, and next class also I will take, that means mathematics class also I will take. Okay, so join the class, the biology student also join the class continuously, that means the two class I will take continuously. So this class also, next class also, mathematics class also. Okay, so next chapter also will start. So pressure it is given 3 into 10 to the power 5, and density of water it is given 1000. Density it is given 1000 kg per meter cube. Okay, and the pressure is also given. So find out the, what is question is asking, find out the velocity, at what velocity the water emerges out, that means the velocity you have to find out. Okay, so who can solve this type of question? So answer will be also, this formula also is also the same, that means this you can use this formula also, v equal to root over of 2gh. But first of all we have to find out the value of h here. We can use the same formula here also, but yes, Suvarna.
So please explain the question once more.
Okay. Question is asking at what velocity does the water amount? It is if it is a water tank, then one hole is here in that particular condition, and water is emerged out from this particular hole. Okay, and it is given that height is not given, but the pressure before the water flowing from the particular what orifice, in that condition the pressure was equal to 3 into 10 to the power 5. Okay, Newton upon meter square. Okay, before the water emerged out at the orifice, the pressure was 3 into 10 to the power 5 Newton upon meter square. It is you are given, and the density of water it is given 1000 kg upon meter cube. Okay, so first of all, the question is asking find out the velocity. At what velocity the water will emerge out from that particular orifice? You have to find out. Okay, so Sugandha. Okay, so that means density it is given 1000 kg per meter cube, and velocity it is you have to we can use the formula v equal to root over of 2gh. But here also h is required. That means h we have to find out first what is the value of h. Then we can use this formula. So h, how can you find out the h? P equal to rho gh. One formula was there. P, that means the pressure inside the liquid, that will be also rho gh. Okay, so if the pressure will be rho gh, then rho it is given how much? Rho it is given 1000. Okay, so g 9.8. So h you have to find out. Pressure it is also given. That means how much? 3 into 10 to the power 5. Okay, so you can find out the h from this particular equation. That means 3 into 10 to the power 5 divided by 1000 into 9.8. So the value comes to, that means you can find out the height. The height comes to first you just to find out the value of 10 to the power 5 it is there, 10 to the power 3 it is there. So 3 into 10 to the power 2 divided by 9.8. Okay, so then you can find out the velocity of efflux. That means find out, question is asking find out the velocity. So you just put the formula root over of 2 into gh. G means 9.8 into h. H is how much? M is this much. That means 3 into 10 to the power 2 divided by 9.8. Okay, so 9.8, 9 point can be cancelled. So you just to solve it. 3 into 2 is 6 into 10 to the power 2 square root. So the answer comes to 6 in 600 square root. It will be 600 square root. It will be nearly equal to 24.49. 24.49. Okay, 24.49. Okay, so this is the value of what? G means the terminal velocity. You can find out by this particular formula. Okay, so next we have discussed this type of numerical. Then comes to next chapter. We'll discuss the next chapter. That means that is the thermodynamics chapter. We'll step to the chapter number 19. That is called, that is one of the important chapter, thermodynamics. So we'll discuss the thermodynamics that will come in the exam also. Okay. We'll discuss the chapter of thermodynamics. Okay. So what is the thermodynamics and what is the value of that means we'll discuss the different factors in the thermodynamics. Okay, that is a new chapter. So we'll discuss the thermodynamics chapter number 19, page number 734. 734. Okay. So you just practice the numerical, whatever the numerical that is discussed in the class. Also you just solve the different numericals also. Okay. So thermodynamics is this chapter particularly based on the heat. This chapter is particularly based on the heat. Okay. So first of all, we'll discuss the some of the basic definition. We'll discuss some of the basic definition that will be used in the thermodynamics. Okay. So first definition is a system. What is a system? System means the system which we are concerned to be a fixed amount of matter enclosed within a surface. Okay, that means if a fixed amount of matter that is enclosed within a surface, that is called as the system. Okay, so the definition is called as the system. Then it is second one is it is called as the yes.
Good morning, sir.
Yes, yes.
Sir, I have some doubt in that flow of liquid chapter.
Yes, yes, yes. We'll discuss the doubt after the completion. I will give you some time. That in 5 minutes I will give you, so you can ask your doubt. Okay. So first, let me thermodynamics chapter. It is a very important chapter that will also come in the exam. So we'll discuss this chapter. Then after last 5 minutes, I will give you. That means you can ask your doubt. Okay. So
Okay, sir.
first one is the system. System means the system is which is concerned. That means amount a fixed if a fixed amount of matter that is concerned in the that particular container. This is called the system. Then comes to what is the surrounding. Surrounding means outside the system. That means everything outside the system under condition is called as the surrounding. Okay, if it is a system outside the system, whatever the substance are there, what are the substance are there, they are considered to be as a surrounding for the system. For this particular system, if whatever the substance outside the system that is there, that is called as the surrounding. Okay, this is called as the surrounding. Okay, then comes to what is isolated system. Isolated system means what is the definition of isolated system? If the surrounding of a system does not have any effect on the particular system, if a surrounding of the system, if the surrounding means this is the if this is the surrounding of the system, this is the surrounding. If the surrounding does not have any effect on the system, that means a system and surrounding, there is no connection between the system and surrounding, then this is called as the isolated. This system is called as the isolated system. Isolated system means what? If the system in between the system and surrounding, if there is no connection, no connection means the temperature will not transfer, all these things will not transfer, then this will be system is called as the isolated system. Isolated means it is isolated from the surrounding. It is isolated from the surrounding. Okay. Then comes to what is a thermodynamic system? These are the basic some definitions are there. We'll read first, then after we'll go to the first law of thermodynamics, zeroth law of thermodynamics we'll discuss. Okay. So thermodynamic system means what? A system that means a state at which at any instant can be completed and defined as the pressure, volume, and temperature is called as a thermodynamic system. In a thermodynamic system, there are three factors, three things are there. That means one is the pressure, and the second one is the volume, and third one is the temperature. Okay, so the three things that can be changed in a thermodynamic system. In a thermodynamic system, the three things that mean pressure, volume, and temperature can be changed in that particular thermodynamic system. So these particular variables, that means pressure, volume, and temperature, these are also called as the thermodynamic variable. Thermodynamic variable. Okay, these are also called as what? Thermodynamic variable also. Okay, so then comes to one is there that is called thermal equilibrium. Thermal equilibrium, what is that word mean? What is the meaning of thermal equilibrium? If the two system, if we are considering two system, that means the two systems are there. This is system number A and this is system number B. Okay, this is system number A and this is system number B. If the temperature of the both the system are equal, if the temperature of the both the system are equal, and so they are called as the, if the temperature, that means the temperature of what system A is equal to temperature of system B, then the system is said to be called as the thermally equilibrium. Thermally or thermal equilibrium. Thermal equilibrium. Okay, that means say if the temperature of body A is equal to the temperature of body B, then both the body are said to be called as thermally equilibrium with each other. Okay, that means we know that heat will always flow from the hot body to the cold body. Yes or no? So if it is a hot body and it is a cold body, the heat is flowing to the conductor. We are just placing conductor in between that. The heat is flowing to the hot body to the cold body. In that condition, so heat will flow up to what extent the heat will flow, up to, that means if the temperature the both the body will be equal, then the heat will not flow, that means it will stop, that means both the body having the same temperature. In that condition we will say that the two body A and B are thermally equilibrium with each other. A and B are thermally equilibrium with each other. Okay, these are the basic concept. Okay, so next come to what is the zeroth law of thermodynamics. One law is there, that is called as the zeroth law of, this is one of the most important law of thermodynamics. What is the zeroth law of thermodynamics? What is the zeroth law says that? Zeroth law says that if we are taking the two system, that means the system number A, this is system number A, and this is system number B. Okay, this is system number A and this is system number B. Okay, in between the system number A and system number B, there is a insulating stand. That means there is no connection between system number A and system number B. That is the insulating material. Insulating material. Okay, there is no connection between system number A and system number B, and the two system are connected with these particular two system are connected with the third system. This is the system number C. This is the what system number C, and this is the system number C, and in between that one conductor is there. Conductor means it is the system, the heat can flow from the system number A to the system number C, and the heat can flow from the system number B to the system number C also. Okay. Okay, so this is the three system we are taking. First is system number A, and this is body number B, and body system number C. Okay, three systems we are taking, and this particular three body we are taking also. So we can call that. So zeroth law says that if the two body or two system, that means if the two body A and B, if the two body A and B are separately connected with the body number C. Okay, if the two body A and B, if the two body A and body number B are separately connected with the body number C, are separately connected with the body number C. Okay, just see that A and B here, there is no connection between A and B because it is the insulated material. There is no connection between A and B. The temperature of body A, that the heat cannot flow from the body A to body B, but the heat can flow from body A to body C, and the heat also can flow from the body B to body C. Okay, so in that condition, just to see that, so what the zeroth law says that according to zeroth law, if we just what we have assuming that the temperature of body A equal to temperature of body C, and temperature of body B equal to temperature of body C. Okay, these things we have taken the assumption. Then according to zeroth law, what the zeroth law says that then the system A and system B will be thermally equilibrium with each other. That means the temperature of body A equal to temperature of body B. If this will happen, that means if the temperature of body A equal to temperature of body C, and the temperature of body B equal to temperature of body C, then according to zeroth law, temperature of body A is equal to temperature of body B. This will happen. Okay. So this is the zeroth law. I am again repeating. If the two system A and B are separately thermally equilibrium with the system C, if the two system A and B are separately thermally equilibrium with system C, then system A and system B are thermally equilibrium with each other. Thermally equilibrium with each other. Okay. So this is the zeroth law. This law is called as the zeroth law. Okay. So if the system A and system B are separately, they are not directly connected, but they are separately connected to system C. Okay. And according to zeroth law, what the zeroth law says that? Zeroth law says that the system A will be also thermal equilibrium with the system B also. Thermal equilibrium means what? The temperature of body A equal to temperature of body B. Okay, that is called in the physics language. It is called thermal equilibrium. Thermal equilibrium means the two body having the same temperature. Okay, this law is called as what? Zeroth law. So, question you should ask the question, sir. Why this law is called as the zeroth law? Why it is not given the name first law, second law? Okay, why this law is given as the zeroth law? Is Sugandha Jaswal.
Sir, explain diagram B also, where insulator and conductors are interchanged.
Okay. Diagram
B.
Diagram B says that, just see that diagram B, in between the A and B, even in between the A and B, there is a conducting material is there. Conducting material means A, the temperature of body A that can be transferred. That means whatever the heat body A, that will be transferred to the body B also. That will be transferred to the body B. And the in between the A and B, in between the see that the figure is given like this. The body A, this is body B, and this is the body C. This is the body C. Okay, so it is what about the material it is given? It is the insulating material. It is the insulating stand or insulating material. Insulating material. Okay, and it is the conducting material. Conducting material. Okay, so if it is a conducting material, that means heat can flow from A to B. If it is a conducting material, so heat can flow from the A to B. But if it is the insulating material, so heat cannot flow from the directly to A to C or B to C in that condition. The second condition, in the this is the condition of a second condition. That means it is the insulating means the heat cannot flow from A to C or B to C only. Okay, so here only heat can flow from the A to B only. Here only heat can flow from the A to B because it is a conducting material. Okay, the next diagram, the next what the first diagram is showing, that first diagram is the opposite of the second diagram. That means the first diagram, in that condition, you just see that it is a conducting material and it is a insulating material. In that condition, it is a insulating material. So A and B that cannot be connected together. That means that the heat cannot flow from the A to B in that first diagram. But in the second diagram, heat can flow from, it is the conducting material. That means heat can flow from the A to B, but heat cannot flow from the A to C and as well as B to C also. The two diagrams are showing the different factors. Okay, so then comes to equivalence of work and heat. Equivalence of work and heat means what? Whatever heat is also a type of what energy. Heat is also a type of energy. And what I am telling that why zeroth law is called as the, why it is the name is given zeroth law. Ron Thomas, can you answer this question? Why this name is given zeroth law, not the first law is given, not the second law it is given? Yes, Ron Thomas.
Sir, because this law was formulated very early than the discovery of the first and second law of thermodynamics.
This law was early discovery. That means first zeroth law was invented, then after first law, second law.
Yes, sir.
Okay. So it is, the answer is incorrect. I am just telling the answer. Listen. So first law, just see that the first law, that is the first law and the second law, that was invented, and after the invention of the first law and second law, zeroth law was invented. Okay, zeroth law was invented after the first law and second law. So you can tell that, sir, it will be given the law, third law also you can give in the law. But this zeroth law is telling about the concept of temperature. Concept of temperature, it is given the given by the zeroth law. Zeroth law was given the concept of temperature, but it was invented the lastly. That means the finally after the invention of the first law and second law, zeroth law was invented. But this law is telling about the basic definition of the temperature. Temperature means what is the how the temperature will flow from the heat, hot body to cold body, or if the two systems are there, A and B, how if there is a temperature can be transferred. That means what the zeroth law tells that if the system A and the system B, they are connected with the system C separately, then A and B are thermally equilibrium with each other. That means it is telling about the definition of temperature. So that means this is the basic definition, and so this law is given zeroth law because it was invented after the invention of the first law and the second law. But as also as it is invented after the invention of the first law and second law, but it was given the, that means zeroth law is giving the what, the definition of the temperature. Temperature means how the temperature is going from the, that means the basic things about the temperature it is telling. So it is called as the zeroth law. Okay, that was the name was given zeroth law. Then comes to equivalence of heat and work. Equivalence of heat and work means what? How the work and heat are interrelated to each other, or what is the relation between heat and work? What is the relation? What is the equivalence relation between what? Heat and work. Okay. So we know that heat is also a form of energy. Okay, heat is also, it is a form of but energy, and work is also a form of heat energy. Work is also a form of heat energy. Work means if we supply the amount of heat to a substance, if it is, this is the system one, system A, and we are giving the heat to the system, then the whatever the particles inside the system, that will do some work. That will do some work. If you are giving some heat to a system, then the whatever the particles inside the system, that will move. Okay, so that means they will do some work. That means work is also a form of, work is a form of heat energy. Work is also a form of heat energy. Okay, so that means we can give the system that we can give the directly heat to the system. If we are giving the directly to the directly heat to the system, that means the system, the whatever the particles inside the system, they will do some work directly. Then after, if you also that some indirect method also, there are some indirect method. Indirect method means we can hammer a system. That means we can hammer a iron rod so that it will be also heated, yes or no? So we can, if it is a iron rod is there, if it is a iron rod is there, we can hammer it. So hammer means if you're just hammering it, so that also heat energy will be created in that particular hammer. Okay, so hammering, in that particular hammering, the heat energy also will be developed. Okay, so that means one Dr. Joule was one of the scientists. He experimented that he's founding one relation. Was found one relation. That means relation is telling that he found that relation, that means 4.18 into 10 to the power 3 joule of work produce the same temperature rise in 1 kilocalorie of heat. If the temperature is rising 1 kilocalorie, if the temperature is rising how much? 1 kilocalorie. In that condition, whatever the heat, whatever the work will be produced, that means 4.18 into 10 to the power 3 joule of work will be produced if we rise the temperature of 1 kilocalorie. That means joule of work is equivalent to 1 kilocalorie of heat. 4.18 into 10 to the power 3, is or no? 4.18 into 10 to the power 3 joule equal to 1 kilocalorie. Okay, 1 kilocalorie also you can write. 1 kilocalorie means Cl also you can write. So if you just kilocalorie means 10 to the power 3 is also there here. So you can write 1 calorie equal to 4.18 joule. Also you can write 1 calorie equal to 4.18 into joule. Yes or no? So if you are taking Q calorie, Q amount of calorie if you are taking, that means how much it will become? 1.4.18 into Q joule. Yes or no? So if you are taking 1 calorie, that will equal to 4.18 into joule. So if you are taking 4 calorie, Q calorie you are taking, that means that will answer comes 4.18 into Q joule. Is or no? So so that means 4.18 into Q. 4.18, that is a constant factor, and Q calorie means if you are taking the if Q calorie is the heat, that is equivalent to W amount of work. If the Q calorie of heat, that is equal to the W amount of work, W equal to what? 4.18 into Q into Joule, is or no? So that will be, so just 4.18, that is the constant factor. So we can symbolize that J into Q. Okay, so J is equal to 4.18. That is the J is called as the conversion factor, and it is also called as the mechanical equivalent of heat. Okay, so it is called as the mechanical equivalent of heat. So it is called as the W equal to J into Q. J value is what? 4.18 Joule upon calorie. Is or no? Joules upon calorie. That means J equal to how much? J equal to W upon Q. J equal to how much? W upon Q. So it will be W equal to JQ. W equal to how much? W equal to J into Q. So J is called as the Joule's constant. So it is the value is the 4.18 into 10 to 4.18. Okay, joules per calorie. And if you are writing 4.18 into 10 to the power 3 joules per kilocalorie also you can write. Okay, so there is not a physical constant, it is only the conversion factor. It is only the conversion factor. That means if you want to convert the joules into calorie, that means if you want to convert the calorie into joule, that means 1 calorie equal to what? 4.18 into 1 calorie equal to 4.18 joule. Okay, this is only the conversion factor, that is called as the 4.18. Okay, then this is the value of what? J. Then will comes, that means next topic is that is the heat work and internal energy. Heat and work and internal energy. Okay, so we'll discuss the later because the time is very less. So if you yes, Ron Thomas asked the question.
Sir,
Yes,
sir, what is efflux?
velocity of efflux.
No, sir, what is efflux?
Only efflux.
Yes, sir.
Okay, okay. In the Torsellis theorem, you have heard this word a velocity of efflux. Is or no? That is called as the velocity of efflux means that is whatever the liquid material, that is if it is a container